All right, thanks for joining me. Today we're going to discuss how to create a mold by using 3D printed components and then make a part that gets cast with resin to create a pizza handle, pizza cutter handle, not a pizza handle, because this is a pizza handle. Stick around. I hope you enjoy it. Future Steve here. I was editing this part one of the video. There's two parts to this video. And the first part is where we go through all the 3D printed components and casting the mold, and then casting the finished product and threading it, etc. And I felt that it really didn't cover a lot of the detail that may be necessary. There are two parts to the mold itself. And when I say the mold, I'm talking about the mold to actually cast the part that we're going to turn. So the two parts are both 3D printed. This is the mother mold where it's 3D printed, and then it has cutouts here, which just happen to be the size of a pencil, that you could poke that through after it's been cast. You cast silicone directly into this piece. It has this profile, and when it's completed, then there is another 3D component, the holder of the molder. And it's printed a little bit shorter. We don't need it to come all the way up. This depth inside is a little bit deeper than the 3D printed piece that we put in there. And this is how we would actually set it up to cast. So this is a 3D printed blank. And if you aren't into 3D printing, then you can skip forward. So it's basically you go into your slicer and you just drop an 1.5 by 6.5 inch block on there. Normally it would be a modifier, but in this case it's just a block. You're going to use the infill that you want for the design. This is Cura's cross pattern. I've done a bunch of different patterns. This one in particular, this is also a cross pattern, but you know, there's a bunch of patterns. A honeycomb pattern is really popular, as well as some of the others like grid or something. What you don't want is a 3D pattern. You don't want something that builds upon itself. Gyroid would work, but you know, there's some of them where you're not going to get resin penetration all the way down. And what you do is you print these with, say, 2 walls, perimeters, and you print it with about 10 to 30% infill. You're printing it without top and bottom layers, and it's going to come off the printer just like this. So then when you take it off the printer, you're going to have this blank that you then cast resin into it. And the end result is this type of block. And then this can be, as you'll see, I sand down the ends so that I have a clean white surface there, like this. And then turn it between centers, just like any other spindle. And then the end result after it's completely done is going to be like this. Ooh. But you can't see that because that's the end result. That's the end product, and that's at the end of video 2 where we go into that. So with that said, let's continue with the process. All right, thanks for joining me. Today I'm going to talk about using a 3D printer in wood turning, and in this case what I'm going to do is show you how to make a mold to cast resin and a 3D printed product into. This is going to be a 1.5 by 1.5 by 6 inch long block is what we're going to end up with. This is what the goal is, and what we're going to do is end up with a mold that makes this silicone and then this receptacle to hold the silicone. I don't have to make it long or thicker because I can use this block. The silicone doesn't bond onto the 3D printed plastics. In this case, this is PETg, which is completely recycled. In fact, this is recycled filament from Greengate3D, made in the US. And what I'm going to do is I've drawn up this pattern in Fusion 360. There is a free version of Fusion 360 that will allow you to do this. It's pretty simple to learn. This one has, as you can see, these holes in it, because after I get the silicone in there and it's all dry, then I can flip it over, take the tape off. This is gaffer's tape. I could take the tape off and then use an air gun to help loosen it up and pull it back out. One word of caution is, in a woodworking shop, if you're using any kind of finishes, any kind of film finishes, sprayed finish, etc., you don't want any silicone itself. So I don't use any silicone release sprays on my molds, and that way I'm making sure that I am not getting silicone all over my shop and gonna foul up paint later on. All right, so let's get to work. Okay, because I don't want to get this spray all over the shop, what I do is I take it and I put it in this box, and then this spray is Ejected Mold Release 33 Petra Release, so it's petroleum based. And what I want to do is sufficiently get it down in the edges without breathing too much of it. And since right now I'm in the shop and all the doors are closed, so there isn't great ventilation, it's not horribly smelling, so I got that going for me. All right, so we're gonna put this aside, let it dry. What you could also do is you could paint the mold with any kind of paint, like a, plastic paint or whatever Rust-Oleum you probably have around the shop, and that would seal it too. There is another mold release that's also a sealer that I'm going to experiment with next that makes more sense, because it makes it anything to make it easier to release the mold. The silicone from the mold is always a benefit. So here's a little bit of math. If I take the inside dimensions for the whole cube, it's 186 by 59 by 49 cubic millimeters, and then subtract the piece is 40 by 167 by 41, 273, I come up with 262,846 cubic millimeters. That really isn't as important, as that equals 16.10 cubic inches. Each cubic inch is 18.23 grams of resin, so I need a total of 293 grams. So what we'll do is we'll put this in at 150 grams of part A and part B. This is a 1-to-1 silicone. It will go in and then at 150 each. 50 grams of part B, and then stir. It's rather thick, and you want to stop, because if you go over, then you're going to end up having to go over on both parts. And I'm a rebel. I pour both of them into the same vessel. And then stir. I'll take that. Then I zero out the scale. I get something to stir it with. That's always helpful. Tongue depressors work great. This is part B. And just by pouring a little bit carefully, we don't go over the 150, especially on part B, because then we got to go back and pour part A again, theoretically. And what's funny is I can, and actually that's good, 149. So what's that put us at, a 0.5%? Not even a 0.5%. We get the scale out of the way. We bring over our vessel here for the silicone. What we want to do is degas the silicone, and you got to work pretty fast with this because it is, of course, fast set. And because it's fast set, we don't have a great working time. And the other side note is that because it is we're putting it under vacuum, it can set faster, because under vacuum, the boiling point of all liquids decreases. So we're going to put that in there. And what we may have to do is, to make sure it doesn't go over, is we may have to feather that a little bit. You'll see this start to bubble. Once it gets to about 20 inches of mercury, a little bit more, it's starting to bubble. You can see it rise in there. We want to make sure that it doesn't boil over, and hopefully it'll burst before it gets there. There we go, perfect. And that's about what we need then, maybe a little bit more. And then we want to let the atmosphere back in fairly slowly, because we don't want that getting all fluffed up. All right. Now what I want to do is pour this a little high and on the top of it, and maybe that way it can break some more of the, by using the surface tension, it can break some more of the air bubbles out. And hopefully we got enough silicone here. I'd hate to think we don't. This is why you want to make sure that you've scraped the sides as you're mixing it, so that the silicone that's left in there is nice and mixed up. So, all right, didn't make too much of a mess. Probably should have put something down here, but now we wait for it to cure. Come back in about 30 minutes probably. Okay, so now we've had time to cure and change shirts, and so what we're going to do now is try and demold this. And I say try because I don't think I've ever done it this way. So we rip off the tape. It didn't inhibit the curing, that's cool. And then what I want to do is clean this up. I take my trusty X-Acto, and I want to trim this and take that lip off, because there's always a lip from the static pressure that makes it pooch up around the edge. And we want to take that off because we want the mold to sit flat in the box. So this is like real time. Whoops, maybe two, okay. And by the way, if you ever have excess silicone, just pour it into a cup and makes these cool Zacto holders. And you can reuse this because almost all the waste silicone will come out in one piece. It could be a little gooey though, depending upon how well you mixed it. All right, and then what I want to do is run this down there and kind of just free up the edge a little and try not to lacerate myself. Although it'd be on video, so it would go viral. Last time I tried doing this, I had it without the recess holes or the access holes in the bottom, and it took me forever to get it out of there. So going the route of the sealer and mold release is going to be the way to go. And you'd never know that I've made dozens of molds this way. But it's always a ongoing process, right? We always want to improve. Push those out a little bit. Just happens to be pencil-sized holes. That was not intentional, but happy accident. All right, and it's already starting to come up, so this was a grand idea. And now we'll take the air hose, and you could see how oh, and of course the compressor is going to start. You can see how that's starting to pooch. It's not bad. It's flexible enough resin that this isn't going to be a problem. Pulling it on like this. Silicone, not resin. Hopefully you'll be able to hear me over the air compressor in the background. Right on. Boom. Okay, now we have our mold. We have its keeper, the container, whatever you want to call it. I'm open to a retainer, I guess. I'm open to suggestions. And then this is our 3D printed block. And we're going to drop that in. I've done the math, and we need somewhere around 300 grams total. And we're going to use a pressure pot. This is Alumilite Clear Slow. It gives you a little bit more open time. Open time meaning the amount of time from when you mix the two components together, the A and the B, that it's going to set. And that is a benefit because I work kind of slow sometimes. I have everything here I need except for paper towels. I'm hoping that we're not going to have a big problem. I want to make sure that I wear gloves because this stuff, oddly enough, gets everywhere. It's incredible. All right. So I'm using just a regular old mixing cup here. Come on, there we go. And I mark my A and B on the container, so I need 150 grams of each. Reset. By the way, we don't need child-proof containers. I'm gonna have to order lids. So I get the Alumilite Slow from turntex.com. I've been buying it there for years. Curtis down in South Texas. I guess it's South Texas, I don't know. By Austin. Has been selling Alumilite for a long time. That and cactus juice, if you're into stabilizing, he's kind of the ultimate source for all of that product. 150 on the nose. I'll go with that. Set that up there. And I'm going to go ahead and mix this. It'll get cloudy and then go clear. That's when you know you have a fairly good mix. You can see it's gone clear. Now I'm going to add Alumilite dye, resin dye specifically. This is going to be black, although you're not going to see me turn a black one, but that's a different story. The dyes are transparent, so you need to make sure you're going to put sufficient amount of dye in the mix, or not enough, whether you're wanting something transparent or not, or translucent, opaque. And the clock has been ticking a little bit. I do have newspaper down because I tend to make a mess. I'm going to pour this into my mold. It's going to be it should be plenty. Oops, we're getting on the side there, getting all rambunctious. It will stick to the plastic, so you need to kind of be good about getting that off of there. And then what you'll notice is, depending upon how level your work surface is, you're going to get the resin moving off from one side or the other. The interesting part is how well I'm going to be able to get this out of there. That is one of the problems with using PETg plastic. And then any extra I'm going to pour into this mold, and that is exactly why I use plastic, or I use newspaper. Then I'm going to put this into my pressure pot, and the pressure pot, I have the regulator set at about 60, which should be more than enough. I want to screw down both sides at a time, or one side, yeah. Both sides at a time across from each other. And now we're gonna set this up to bake. It'd be embarrassing if it blew up in my face. Well, other than the pain. $64. All right, we're gonna let this cure for say an hour, and we'll come and check it out then. Let's see how it came out. Big noise. All right. No pressure, literally. See, the stuff just doesn't dry. All right. So here is, it's a little sticky. The main area isn't sticky. So we'll come back to that. And so let's set this aside and look at how to do some finish work on it. All right, let's clean this up a little, get some of this wet stuff off here. The more you can clean this up, the cleaner your container is going to be. It'll all dry eventually. Probably a good idea to hit this with some green wax or something that would seal up the plastic. But this is bonus reel footage. All right, it's everywhere. Everything gets everywhere. Everything everywhere all at once. So probably need to put some reliefs in here so that it's a little easier to get out too. Since this is a solid model, I'm not worried about it distorting. If it were, you know, just a single piece like a pen blank or something without any structure, I would let it cure longer. But it's too cool. I mean, we got to check it out, right? 20 minutes later. You could actually put the silicone portion and the model into an oven and cure it also. The silicone isn't going to be affected by the temperature at all, as you know, any more than the temperature that the resin gets. You can see we got a little there. The temperature the resin gets when it's curing, which, for fun fact, is called an exothermic reaction. So we can take this out of here. It's a little gummy. But the part that we want isn't. The mold is made a little bit taller than the piece itself because you could see that it rode up here, which is fine. That'll all get cut off as we go to work it. All right, what we want to do really is just trim this up so we can put it on the lathe. Need to cut the ends off because the mold is a little bit bigger than the plastic piece, and make sure that this is flat. I run a piece of Abranet across at the bottom here to make sure that it's clean, and then we're going to run that through the saw here, and we're gonna see how much we can clean it up. So when we take it to the lathe, it isn't going to be just this horrible chunk of plastic we need to get rid of first. Squeakies. A little bit off here, but that's okay. What we wanted to do is make sure that's where we were at. That's off a little bit as well. We'll have to fix that on the bandsaw, on the sander. There as well. Now that we got these somewhat squared away, what I want to do is go ahead and square this up. And the whole reason for that is when I use this for a pizza cutter handle, I want to have white all the way across, as in knife terms it would be a liner. But what it is just a good color delineation between the stainless steel and then the pattern that comes after it. So I have this makeshift disc sander set up on the lathe. This is a 12-inch base. I don't even know where I got it from. I've had it for so long. With some PSA 120 or something like that. And then I have my dust collector here, and we're gonna square these up a bit. You don't want to go too fast because it is a plastic that you're grinding down. That should be all right on that end. I suppose I could set up a miter table here, but that would take more work. It would no longer be impromptu. Clean this off a bit. It does tend to get built up from plastics and resins. So you can see we have this little spot here. We're trying to get that white all the way across. Hopefully that's pretty square. That looks good. So what I do initially is use a center finder and set this up to hit the middle. Accuracy is great, but it's dead center in the middle isn't going to make that much of a difference. And then I bring up my C-clamp, clamp it down so I at least have some point of anchor. Things flying off the drill happen very fast. All right then. Okay, so here's a tap-in setup. We got the tap set up here. We got a center finder here. The idea is to guide this in and pull down at the same time. It'll be self-feeding at this point pretty soon anyway. I'm not using any lube. It is pretty soft material, and I'm gonna have to pretty much bury this tap. I guess the only way I'll know if it's straight is when I put it on the mandrel. I mean, I'm not really in fear of breaking the tap as much as I am of stripping the holes. Although you could fill it with epoxy. And the seagulls are here. All right, let's check that out. Ooh, that doesn't help. I want to make sure that that thread's in there good. Uh-oh. Beautiful. Okay, now that we got the mold made, we went through the whole process of casting it. We got it out of the pressure pot, out of the goo. We've squared it all up, etc., and threaded it, which that probably was the most meticulous way to thread it. And there's got to be a faster way. We'll try it on the lathe at one point. Anyway, so now we're ready to turn it. I know, right? But that's the next video, part 2 of pizza cutter handle. Hope you check that out. Click subscribe, like, tell your friends, eat some pizza. Thanks for watching. Have a good day.